Hi everyone, Ravi this side. Welcome to EnggAdda. Today in this video, we are going to discuss about the Stream API, one of the most important feature introduced in Java 8. So let's get started for that, and let me try to discuss about the Stream API in more detail. And later on, we'll practically try to create a project, and there we'll try to see the practical implementation of the Stream API introduced in Java 8. So let's get started. Let me try to go to the next slide and discuss about the Stream API first. So, what is a Stream API? The Stream API in Java is a powerful addition introduced in Java 8 that enables functional style operation on sequence of element. So, make sure you remember this term, functional style operation on sequence of element. So, the Stream API help us in writing the code in functional style on sequence of element like list or sets. So this is what the main agenda of Stream API is. It enables the functional style of coding on sequence of element. It operates on collections of objects, allowing for concise and expressive code to perform the operation like filtering, mapping, sorting, and many more. So Stream API help us in doing the filtering, mapping, sorting, and many more others experiment on the list of objects, on the collection of objects. So this is about the introduction of Stream API. Now let me try to go to the next slide and discuss about the stream. What is a stream? Okay. So the stream is a sequence of element supporting sequential and parallel aggregate operation. Okay. So stream is nothing but it is sequence of elements supporting sequential and parallel aggregate operation. A stream does not store elements. They convey a pipeline of functions to transform a data. So let's say you have a list and you want to convert that list into the stream. Now you have converted that through some methods, okay? But you cannot store the stream how you store the list. You can only convert one list into the stream or transform the stream into the stream, but you cannot store it out. So stream does not store element. They convey a pipeline of functions to transform the data. Now, a stream can be created from the various data sources like collection, arrays, input-output channel, and generators. So, make sure you remember this, that we create the stream out of collections or arrays. So, this is what we are going to discuss in this examples as well. So, what we'll do, we'll try to create a list or let's say arrays of element, and then we'll create or convert that list or arrays into the stream and then perform the stream functions on that, and then we'll try to get the result. So this is about the stream. Now let me try to go to the next slide and discuss about the functional operation in streams. So when you are going to have an interview related to the Java or Spring Boot, and if they are going to ask about the Java 8, they will come to this question of a Stream API. And they will ask you about the functional operation in the stream as well. Like they will ask you about the intermediate operation. What do you mean by intermediate operation? And what do you mean by the terminal operation? So intermediate operation and the terminal operation are called as the functional operation. And we are going to discuss them one by one through the example as well. So first of all, we are going to discuss about the intermediate operation. So these operations can be chained one after another and return a stream. So let me try to tell you that. Let's say you have a list of elements. You converted that list of element into the stream through some function and you get the stream. Now you want to work on that stream and produce the stream itself, not the list or not something else. So those operations that are working on the stream and then again producing the stream. So make sure that the input and output of that function is a stream. So those are called as intermediate operation. Okay. So these operations can be changed one after the another and return a new stream. So example of those elements are filter, map, flat map, sorted, and distinct. These are the example of intermediate operation. They work on the stream and they produce the stream. They take the input out of the stream and then produce the stream. Okay. Now let me try to one by one tell you about the filters, map, flat map, sorted, and distinct methods. So let's say what is filter method is doing. So filter method in this stream filters the element based on the given predicate. So in the previous video, we already have discussed about the predicate, supplier, consumer, and function-functional interfaces. So the filter method takes the predicate in their method argument, and according to that predicate, it will give you the result. So the predicate is, in the predicate, we have to provide some condition, right? The same way in the filter, we have to pass the predicate. In that predicate, we have some condition, and based upon that condition, it will filter out the list of element and then give you a filtered or transformed stream. Okay. So this is about the filter. Now coming to the math, this transform each element using a provided function. So map takes the functional interface, and according to that, it will work and give you the transform element. Now coming to the flat map, it flattens the element after applying a function that returns a stream of each element. Coming to the sorted, this sorts the element of the stream, and distinct, it removes the duplicate out of your stream. So this is about the intermediate function, or you can say intermediate operations. And there are a lot others intermediate operation. You can search it out and you can learn on them. We have discussed this top intermediate operation that are being called or that are being asked into the interviews. Okay, now let me try to go to the next slide and discuss about the terminal operation. So let's say you have a list of element, you converted that list into the stream, you applied the intermediate operation like filter on that and get the stream. Now you want to store those elements in some list. You want to store those stream elements that are being filtered out into some list, or you want to print it out. You want to end the operation. Then the terminal operations or terminal method you have to call on that pipeline. So these operation terminate the stream pipeline and they produce a result or a side effect. So it will give you, it will take the stream as an input and give you some let's say list or some others entity that you can end with, or that you can print out, okay, or that you can store. So this operation terminates the stream pipeline and produces a result or a side effect. That is why they are called as terminal operation. Now these are the example of terminal operations or methods you can say, like for each, collect, reduce, count, any match, all match, none match, and there are many more. These are the main, that is why we have listed out here. Now let me try to explain you one element or one operation at a time. Let's say for each. So this performs an action for each element. So let's say you call this for each method, which is a terminal method, and this for each takes the consumer as an input. Now you want to print out each element out of that stream. Then you can simply pass the system.out.println there through the, let's say, method reference or through lambda expression, and trying to print out those elements. So basically this for each takes the consumer. You have to provide the consumer there. In the consumer, you can either print it out or you can do whatever thing you want to do. So this is the best example that I have told you about the terminal operation for each. Now coming to the next terminal operation, which is collect. In the collect, you can pass, let's say, collection.list to store the filtered element or to store the transformed element into the list. So this reduces element into a collection or a summary. Coming to the reduce, this perform a reduction on the element using the binary operator. Either you can add it out or subtract it out inside the reduce. Coming to the count, this return the count of the element, and the others method like any match, all match, none match, check for the matching element based upon the condition. So these are about the terminal operation, and there are many more. You can learn on them. Now let me try to go to the next slide and discuss about the basic workflow, or you can say the workflow of a stream. How you can create a stream, how you can apply the intermediate operation on it, how you can apply the terminal operation on it. So those things we can, we are going to discuss here. What is the basic overflow, or what is the pipeline of the stream? So first of all, you have to have a list or arrays, or you can say the list of element or collection of element you have. Then on that, you will convert that list of element into the stream. So either you can convert it through the stream method, like how for the collections, let's say you have the list, then you are going to call the stream method on the list to convert that list into the stream. Similarly, for the set, you can call the stream method and convert that set into the stream. Similarly, for the map and for the arrays also. Now, stream generation methods, there are other stream generation methods like stream of, stream iterate, and stream generate. So let's say we are going to discuss about the stream of. So let's say you want to generate a stream of numbers. So you can do is stream.of, and then inside that of you can provide the list of numbers, list of integers there, and that will give you a stream of numbers or stream of integers. Similarly, you can also do the stream of iterate and stream of generate. So this is how you can create the stream. If you have the list, you can directly call the stream method on it. If you don't have the list, you can call this method stream.of and then provide the element inside it, and it will give you a stream. Now let me try to go to the next slide and discuss about the intermediate operations. So after you have created a stream, you can apply these intermediate operations. Like for the filtering, you have to filter, you have to provide you have to call the filter method, and inside the filter method you have to provide the predicate. Similarly, for the mapping, you can call the map, you have to provide the function inside the map. For sorting, you have to call the sorted method, or you can call the different version of the sorted method where you have to provide the comparator. For the distinct, you can directly call the distinct method on the stream. So these are the intermediate operation. Now you have created the stream, you have applied the intermediate operation. Now you have to apply the terminal operation. So make sure that there is you can apply more than one intermediate operation, right? And then you can apply the terminal operation. Like we already have discussed about the for each to perform an action for each element. If you want to collect out, you can call the collect method. Similarly, if you want to reduce, you can call the reduce and count, and there are others as well. So these are the terminal operations that you can apply after the intermediate operations. Now this is about the stream, how you can create a stream and how you can work on the stream pipeline. Now let me try to go to the next slide and discuss about the benefit and use cases of the stream APIs. So they will help you in writing the concise and readable codes. Okay, so stream APIs enables writing compact and expressive code, reducing the boilerplate. Okay, so stream APIs will help you in writing the concise and the readable codes. Now coming to the next point is efficient and the parallel execution. Streams can exploit parallelism when working with a large dataset by transparently partitioning workloads. So this will help you in exploiting the parallelism in your code. Now coming to the third point, which is declarative style. So focuses on describing what to do rather than how to do it, promoting a functional programming style. So this is a benefit and use cases of the stream API. Now let me try to give you one example of the stream API. So here you can see we have the list of numbers, or you can say the list of integers 1 to 10. Now how you can convert that list into the stream? Through the stream method, right? You can call the stream method on this list and it will be converted into the stream. Now you have converted that list into the stream. Now you have to apply the intermediate operations. Like first we are going to apply the filter, which is filtering out the even numbers out of this stream. And then we are applying the second intermediate operation, which is map. And we want to transform that list of or stream of the numbers which are evens and make them double. Okay, and then we are simply applying the terminal operation, which is collect, and then we are collecting that into a list and simply storing that response into the even double numbers and then printing it out. So this is one of the example of the stream APIs, how you can play with the stream APIs. Now let me try to go to the next slide. Okay, so this is about the basic of what I would say a basic introduction of the stream in Java 8. Now what we'll do, we'll try to go to the IntelliJ and create a simple application, and there we'll try to replicate these things that we have discussed, and practically we'll try to implement a lot of example related to this stream. There is 2 videos on my channel where I have discussed a lot of questions which are being asked in the interviews related to this stream, and we have solved a lot of problems there. So I will provide the link of those videos in the description as well. You can go and watch it out. Here what we'll do, we'll try to go to the IntelliJ and create a simple application and then try to implement a lot of example of the stream. So let's get started for that. Now let me try to come out of it and go to the IntelliJ and create one Java project. So let me try to come out of it and here go to the IntelliJ. Now create one Java project. So go to the file, new, and go to the project. And let's say it is a stream API demo, something like that I am going to create. Okay. And it is a Java project, and let me try to create it out. Open it in a new tab and wait for a few seconds to load it. Once it is loaded, then we can start doing the development. So just wait. I think it is good to go. So what we are going to do is we are simply going to see how we can create a stream, and we are possibly going to use all the intermediate and the terminal methods that we have discussed, or intermediate and terminal operation that we have discussed in the stream API. So for that, let me try to create one, or what we can do is here also we can do the same thing. Let me try to come here to the main method and try to create a stream first, and then we'll try to apply those methods and then see. Okay. So let me try to comment out this piece of code, or what we can do is we can test it out. Let me try to run this and then see if it is working or not. It will work, right? So just wait for a few seconds, and here you can see we are getting the hello world. Now let me try to comment out this piece of code and try to do one thing is try to create a list of integers, and then we'll try to perform the operation on that. So whatever we have discussed here you can see we have the list of numbers, and it is from 1 to 10, and then we are applying the filter map and then collecting it out. So we are going to create a list of numbers first, and then after that we'll try to perform various operations on this list. Like first we'll try to create a stream out of it, and then we'll apply the intermediate and the terminal operation on it, and then see the results. So what we are going to do is, let's say we are going to create a list of integer, let's say it is numbers, and here you can do is let's say arrays dot as list, and then you can provide the numbers here. So let's say 1 2 3 4 and till, let's say we are going to keep it till 11. Okay, now let me try to import this list here, and we are good. Now we have the list of numbers here, and now what we are going to do is we are going to create the stream out of it. So just create a stream, and then let me try to show you the intermediate options or intermediate operation that are available. So you can see that we have the map we have the map, filter, sorted, and distinct, find any, all match. So these are the intermediate operations that you can apply here on the stream. So first of all, what we are going to do is we are going to apply the filter and then see the result. So in the filter, you have to provide the predicate. So if you go inside the filter, you will see that there is only, like, it is taking the predicate here, right? And if you go to the predicate, you will see that there is one single stack method, which is test, and it is t, taking t as an input and returning a boolean out of it. So we are directly going to implement the single stack method of the predicate here in the filter. So how we can do that? Let's say we are going to filter out the elements if they are even or not. So based upon that, we are just going to filter out the elements or a stream of elements or a stream of numbers. So the condition you have to provide here is you have to check for the even numbers. So for that we have to, like, the number should be divided by 2, and that would be the even number, right? So this is the condition for that. And now what we are going to do is we are just going to simply apply the for each and try to print out each element one by one. So what you can do is either, like, if you'll go inside the for each, it will ask for the consumer. You can see that, and in the consumer you have the accept method, which is taking t as an input and not returning anything, right? So what you can do is you can using the lambda expression, you can directly come here and print out the each element one by one. So the same way, like, this is how you can do that. Or there's another way, I will show you that as well, which is a method reference way of printing out the element, or you can say, or replacing the lambda expression. So let me try to run this piece of code and then show you the result. So here you can see we are getting the result. We are getting the even numbers, which is 2, 4, 6, 8 and 10 out of this list of numbers, which is from 1 to 11. So what we are doing is we are applying the filter. We are passing the predicate condition here, and then we are printing out each element one by one. Okay, now if you want to replace this lambda expression, then you can directly use the method reference at the place of that. So just go to this system.out, and then you have to pass the method reference, like double colon and then println. This is one of the method reference, which is static method reference. I already have discussed all these things in the previous videos, so you can go and watch it out. Now let me try to run this and then show you the result. So here you can see we are getting the result. So everything is working fine, and now what I will do, let me try to show you how we can use the map function here. Okay, so we have used the filter one. Now let me try to use the map here. So let me try to introduce the map here itself. So what we are going to do is, first we are going to filter out the elements or the numbers based upon the filter condition, which is we are filtering out here the even numbers. And now what we are going to do is we are just going to multiply the filtered numbers by 2 or by 3. Okay, so let me try to convert that filtered numbers and into some, like, transform that filtered numbers by multiplying them by some n numbers, okay, or n integer, you can say. So what this is what we are going to do. So let me try to just rearrange the code, and then it will look good. So let me try to rearrange it. So we have the numbers. On the numbers, like, we are converting that numbers into the stream and then applying the filter. And then what we are doing is we are just going to print it out. Now let me try to apply the map here. So just let's say it is map, and in the map, if you'll go inside the map, let me try to rearrange it. Okay, so we are not able to do, no problem. So if you'll go inside the map, you will find this, it is taking the functional interface. If you'll go inside the function, you have this apply method, which is taking t as an input and returning r as an output. So the same way you have to like, implement the functional interface here. Okay, so it will take 2 inputs, and like, it has it will take one input, which is t, and it will return the different output, which is r. Okay, so let me try to implement the functional interface here inside the map. And let's say we are inputting t, and then we want 2 into t. Okay, so 2 times t out of it. Okay, so this is what we are going to do. Now after that, what we are doing is we are just iterating each element and printing it out. So just run this application and then see. So here you can see in the result we are getting the expected output, which is we are first filtering out the list of numbers based upon the condition, which is we are filtering out the even numbers. and then we are multiplying the each numbers or each element by 2. So you can see we are getting 4, 8, 12, 16 and 20. Okay, so this is how you can apply the filter and map here. Now let me try to show you some others intermediate operation here. So we have discussed about the filter and map. Now let me try to show you about the this distinct. So this will try to give you the distinct element. So let's say there is a possibility of having the duplicate element. So it will remove that duplicate element and it will try to give you the distinct element. Okay, so let's say we are going to apply the distinct here. As of now, we don't have any duplicate element inside our list. So let me try to put some duplicate elements here. So let's say and let me try to remove this map from here. So what we are going to do is we are just going to simply filter out the elements, like filter out the even elements, and then we are checking the distinct on it, and then we'll try to print out. Okay, so let me try to remove this map as of now, and let me try to remove these distincts right now, but later on we'll put that thing as well here. So let's say we have we are putting the duplicate elements, like 8 is 2 times, so and let's say 6 is also 2 times. So we have two duplicate elements, 6 and 8. Okay, now what we are going to do is we are going to first convert that into the stream, filter out the even numbers and print it out, and then we'll show you the use case of the distinct there. So just run this application and try to see. So here you can see we are getting the duplicate elements, right? 2, 4 and 6, 6, 8 and then 10. So we are printing out the duplicate element as of now, but when you apply the distincts here, you will not see this duplicate element. So let me try to apply the distinct method here and then try to run this application and then see. So here you can see that we are not getting 2 times 6 and 2 times 8, right? The duplicates are removed from the list. Now let me try to discuss about the other intermediate operations like sorted. Okay, so let me try to remove the distinct from here. And for the sorted, let me try to put couple of others numbers here and make this list as a unsorted list. So let's say we are going to put some duplicate numbers here. Let's say 7, 6, 5, 4 and 2. Now let me try to run this and then show you how the list is looking like after the filtering. So you can see that we are getting this 2, 4, 6, 6 and 8, 10, 6, 4, 2. So the list is not sorted, right? It is not in the sorted order. Now what you can do is you can apply the sorted here. So just look for the sorted. So you can see that we have two sorted methods. One is without the any argument, and the second one is the taking argument, which is comparator. So the first one is used for the default natural sorting order, and the second one is used for the customized sorting order. So you have to create a custom comparator there, and you have to pass how you want to sort your elements according to that. So let me try to use the default natural sorting order as of now. So let me try to use the sorted method. I don't pass any comparator there, and try to run the application again and then see the result. So here in the result you can see that the list is coming as sorted list, right? We have the sorted elements here. So this is the work of the sorted intermediate operation. Now we have discussed about filter, map, distinct, sorted, and there are many more intermediate operation you can use, and you can work on it, and you can try to experiment with them. Okay, now let me try to move to the terminal operations. Okay, let me try to discuss about the terminal operation. As of now we are only discussing about the for each, right? This is one of the terminal operation, and we have used we have seen the use cases of this for each method. Now we'll discuss about the others terminal operations here and then show you the results, how they are behaving. So let me try to remove this sorted, and let me try to revert back our let's say the list to the sorted list. Okay, and we are just putting this 11 here. So what we have is we have the list of numbers from 1 to 11, and now we are converting that into the stream, filtering it out, and then we are just simply printing it out. But what if I will tell you that, I will ask you that you have to keep this filtered elements in some list. So how you can do that? You don't print it, just keep it in some list. So how you will do that? So let me try to show you how you can do that. So there is a method called collect. So you have to call the collect here, and then inside the collect you have to pass a list. Okay, so if you want to store this elements, filtered element into the list, so you have to use the collectors.toList. Okay, so just call this collector.toList method here, and then you are good. Now we have to store it, so just let me try to create one variable here where you can store it, and then simply we'll try to print it out. So let's say it is result, and then we are storing it out here, and then just copy this result and write a print statement here and put the result there. Okay, now just run this application and then see the result. So here you can see that we are getting the filtered elements, and it is inside the list. Okay, so this is how you can collect your element into the list using the collect method, which is a terminal operation. Okay, now let me try to remove these duplicates from here, and then okay, so we are good. Now if we'll run it again, you will see the result. So you can see that, right? Now let me try to discuss about the other terminal operations. Like, let me try to remove this first and then see what is coming. So you can see that there is a reduce, and after that we have all match, we have count as well. So we'll discuss, let me try to discuss about the count first. So it will give you the count of elements that you have into the stream. Okay, so let's say we just want to have okay, why you are getting this? Okay, now let me try to print out this answer here. So you can see that when we are filtering out our elements, like even elements, then we have only 5 elements which are events out of this list, right? So you can see that the count is 5. So it should print 5 here. Now let me try to run this and then show you the result. Okay, so just wait. I don't know why it is taking time. You can see that the result is 5 here. So the count is also working fine. If you want to have the count of the elements from the stream, like it is taking the stream as an input and giving you some result that you can write down, that you can store. So the count is trying to check for the count of the element into the stream. Okay, so this is about the count. Now let me try to show you how we can use the reduce here. So just go to the reduce. There is a 3 version of reduce. If you go inside the reduce, you can see that it is taking this T and binary operation. One is taking the binary operation, and the third one is taking the U and bifunction and binary operation. So let me try to show you how you can use the reduced by giving you one example here. So let me try to go to the main, and here you can use the reduced for like trying to sum the result, or trying to do the subtraction on the result, try to do the comparison on the results. So you can use this reduce here. So these are used for that. Okay, if you want to, let's say, multiply all the elements into the stream or into the list, then you can use the reduce here. If you want to sum all the elements into the list, you can use the reduce. If you want to do some operation on all the elements, like collective elements, you want to sum all, you want to multiply all, then you can use reduce. So that is what the reduce is used for. It is used for the aggregate operation. So let me try to use the reduce here to sum all the elements that we are filtering out. Okay, so first let me try to simply print out here. So just for each, and you can say that system dot out dot println, and we are not going to store it out. Let me try to remove it. I just want to show you what the result we will get, and then what would be the sum of those elements. So let me try to run it and then show you. So here you can see that we are getting 2, 4, 6, 10 and 2, 4, 6, 8 and 10. If you sum all of them, what would be the sum? 2 and 4, 6, 6 and 6, 12, and 8, 20, and then 10, 30. So the result would be 30, right? Now let me try to do one thing. Let me try to use the reduce here and then show you the result. And we have to put it somewhere in some result variable. So let me try to create that, and let me try to convert this whole thing into the integer. Okay, now here you can use the reduce. So in the reduce, you have to pass these two elements, and it will take two elements from the list, try to do the operation on that. So let's say we are taking 1 and 3, or let's say we are taking 2 and 4, and then what we are going to do is we are going to sum it. Okay, so it will try to sum these two elements and then give you the result. Okay, so let me try to remove this and then see why we are getting this error. Okay, it is asking me to create a response of optional integer type. So just do it, and then let me try to print out this result here, and just uncomment this piece of code. Now run this and then see the result. So you can see that we are getting the result as 30, right? It is coming in the optional because we are using this optional variable here, but you can figure out how we can remove the optional and try to store it into the desired variable that we want into, or desired data type that we want into. Okay, now this is about the reduce. If you want to sum all the elements, then you can come here and use the reduce. Now let me try to show you if you want to multiply it out. So just replace this and then put a multiply sign here, and then you can see the result. So the multiplication would be 3840. Okay, so this is how you can use the reduce. Okay, so this is about the basic thing about stream, how you can create the stream, how you can apply the intermediate operation on the stream, and how you can apply the terminal operation onto the stream. So this is about the basic of a stream. I already have 2 videos on my channel where I have discussed about the Java interview asked codes on stream. So you can go and watch it out. Like there I have discussed about how you can filter out the list of employees based upon the salary, how you can filter out the list of employee based upon the age or the second highest salary. So those kind of question I have discussed there in those videos. You can go and watch it out. If you want me to cover a separate video on the stream again, where we want to have the stream operation on the custom objects, or the custom let's say Java object that we have created, like employees object, student object, then let me know. I will create a different video on that, a separate video on that. So this is about the video, guys. If you like the video, please hit the like button and please subscribe the channel for more such content. Thanks.